Welcome to Brain Vision.
Welcome to a new problem. This time we have east-west direction. We have a motorized cart, and it's moving in the east direction with an acceleration of 2.80 meters per second squared. And then on top of the cart, we have a crate. I don't know what the crate has. Maybe it has a bunch of things. We also have someone pushing the crate, pushing it that way, in that direction, on a surface going eastwards, with the force, which is a variable force, so it's dependent on the time, and that's why you have the domain as t, so 5.40 newtons per second times the time. And we want to find the instantaneous force after 5 seconds. So 5 seconds, maybe it's somewhere right there. So after 5 seconds, we want to find the instantaneous power. So power instantaneous after 5 seconds. So then a faster way of determining the power at any position when there's a velocity involved is to use the power equation, where a force, the specific vector force, is connected to the specific velocity. These two quantities happen to be vector quantities, but their dot product is going to give a scalar value. So we have to get the force at 5 seconds, and that means you take the 5.40 newtons per second times the 5 seconds. That's going to give us 27 newtons as the force at 5 seconds. We need to find the velocity at 5 seconds. We'll call that V final. Kinematic equations say that V final equals to V initial plus AT. The initial velocity is 0 meters per second because the cart at this point, when time is 0, doesn't have any velocity. So we're only left to see that the V final is the acceleration times the time. The acceleration is 2.80 meters per second squared, and then you multiply that by the time of 5 seconds, and that's going to help us get the velocity at 5 seconds, which is 14.00 meters per second. Once we have the vector velocity and the vector force, this is the vector force, we can combine those two in this equation, and so 27 newtons times 14 meters per second. And because this is a dot product, there was going to be a cosine theta at the end, but then theta is 0 degrees, and that's going to give us 1. So it doesn't make a difference because the cart and the crate are moving in the horizontal direction. So if you multiply 27 and 14 meters per second, 27 newtons and 14 meters per second, you get 378 watts. Remember, a single watt is the same as joules per second. The power of an object, or the power of any motorized object, kind of like tells us the rate. So power has to do with the rate of energy transformation. At the advanced level, you start dealing with power in terms of efficiency and stuff like that. But hope you enjoyed the problem. This is power transformation. And feel free to ask any questions, send any questions or comments my way, and have a wonderful day. Okay, thanks. Bye.